No, record. Alright. Alright, here we go. So it's Wednesday, October 15th. This is in 5.7. And this is the fundamental theorem of algebra. Fundamental theorem of algebra. Right here. Fundamental theorem of algebra is, I'm going to just give you the most important part of it. It's long and there's a corollary with it, but I'm just going to give you the part we need. So it is an nth degree polynomial. An nth degree polynomial. And let's just pause polynomial. Let's just pause for a second. How do you get the degree from a polynomial? It's not the leading coefficient. Highest. It's the highest. What do you look for? Exponent. You look for the highest exponent. Good. That's the degree. Okay. Is it ever negative? Trick question. No, because then it wouldn't be a polynomial, right? That's a different unit. Okay, so it's not going to be negative. So an nth degree polynomial, you look for the highest exponent, has exactly n zeros or solutions or roots. Has exactly n. I'm going to say solutions. But when I say solutions, I mean it's the same thing as saying the zeros. Like when you set y equal to 0, what's the solution, or roots. Like you might see any of those words, n solutions or zeros or roots. Okay, so that's the fundamental theorem of algebra. So when we're solving something that's like 5th degree, we're looking for 5 solutions. Now granted, however, some of those solutions may be double roots or imaginary. So it doesn't mean there's 5 real solutions. So some may be, that is too, not going to see that, are you? So the caveat is that some may be double roots or imaginary, or triple roots. Maybe double roots or imaginary. But in the end, there's n, if it's nth degree, there are exactly n solutions. So then we know what we're looking for. So let's do some examples here. Let's try, so for example, I'm just gonna break it down for you. Let's say we had this polynomial x cubed minus 5x squared minus 8x plus 48 equals 0. Okay, let's say we're starting with that. Let me just zoom in here. And magically I'm going to factor it for you. We're going to go through the process in a second. But let's just say this factors to this. X plus 3 times x minus 4 squared equals 0. Okay, the solutions are, what do you think? We use the zero product property, right? So what's the solution here? -3 for this factor. What about here? Okay, so how do you explain that? What's going on there? I just said the fundamental theorem of algebra. What degree is the polynomial? It's cubed. It's degree 3, but there's only 2 answers. Is it flawed then? No, because this 4 right here, because it's squared, it's called a double root. So it counts twice. So that, and it has implications when we graph it, but that's for another day. So it does have exactly 3 solutions, -3 and then 4, but 4 counts twice because it's squared. It's like called a double root. So those are the solutions, and one of them is a double root. Now, so if it were cubed, that would count 3 times. It would be a triple root. If it were to the 4th power, it would count 4 times, etc. So let's do an example where we actually have to factor it ourselves. So let's try. And here's the directions actually for what we're going to do now. And the goal for today basically is everything we do is find all the zeros of any polynomial function. Find all zeros of polynomial function. So that would be like a test objective, an important one. Okay, no graphing today. It's all algebraically. Without graphing, how do we know? Because if we could graph it, how would you find them if we were able to just graph it? Yeah, just look at the x-intercepts. You could trace it on your graphing calculator and be like, oh, there's the answers. Calculator will tell you. So we're going to do it without looking at the graph. F of x, without having to graph it. X cubed plus 7x squared plus 15x plus 9. Okay, so we want to find all the zeros of the polynomial function. Those are the directions from your homework. Okay, that's the goal. Okay, so there's this other theorem that I'm avoiding using and may not because it's difficult to prove, and it's just something. It's another thing to memorize, and I don't think it's necessary. But we have to get started here. In last night's homework, I told you one of the solutions, right? I said, like, given that 4 is one of the solutions, go from there, right? And then you would do synthetic division with 4, right? But now I'm not telling you. So that's the only piece I'm adding, is I'm not even telling you where to start. I'm just giving you this blank slate, okay? So there's a rational root theorem that says that all the factors of this constant over this leading coefficient are the list of things to try. 1 is often in that list. So we're going to just try 1, and then we'll try, if that doesn't work, we'll try -1, then we'll try something else. So let's try. We don't know where to start, and so you have to just try things. So we're going to try to put 1 in the box, and if that works, then x minus 1 is our factor, and we can break it down and get started. Because otherwise we have no idea what to do with that, right? We have no idea how to factor that. So let's see if 1 works. And this is why you need the quick way. You need the synthetic division, because if you did long division, it would just take forever to see if x minus 1 divides into that. And can you imagine doing a long division problem every single time? So let's try 1 in there. So we go, okay, well, are there any missing terms? 3, 2, 1, 0. We're okay, right? So the coefficients are 1, 7, 15, and 9. And so we just quickly do synthetic. So let's see here. What's the first step, Brian, with the C-mama for synthetic division? Good. That's our copy. And then next up, Ashley. And good. Multiply 1 by 1. And then Delilah, add. Good. Okay, so we did 1 round of C-mama. Now we keep multiplying and adding. Multiply, add, 20, multiply. Okay, now in this, you're gonna see, like, you get to say nope. Once you know that you're not gonna, you want the 0 remainder, because remember the remainder factor theorem we learned last time. You need a remainder of 0 so that this would be a part of the factor. But it doesn't work. You don't need to finish it. It's just nope. And then you try -1, because that's just going to be most common. And when you do your homework or on a test, I will give you some kind of clue so that you don't have to do more than a few of these to test. But this is literally like what you have to do to figure it out, is to try.
As long as you get 0 as a remainder.
Yes, we want 0 as a remainder. That's our goal. Why do we try 1? And -1? We're just, it's like guess and check. Yeah, exactly. I know. That's why I'll normally give you a hint as to how to proceed. So copy, multiply, add, multiply, add. Is this going to work? Nice. So, yes. Okay, so back to our original goal is to solve it, right? We want to find the zeros. The only way to do that is to factor. So we know, since -1 works, what's the factor? X plus 1, right? It's the opposite because of the zero product property. Yeah? It's x plus 1. And then what's left over? Tell me, how do I use these coefficients? 1, 6, 9. What does that mean?
6 squared.
1 x squared plus 6x. Right. Okay, so I have that equals 0. Now, do I have to go through this whole synthetic division process for x squared plus 6x plus 9? No. You already know how to do that. This is more practice with factoring trinomials. And we get to use the shortcut because there's a leading coefficient of a 1. We don't have to go to any rectangle. We just do diamond, what multiplies to 9 and adds to 6. Yep. Looks like a double root to me. Okay, so the answers are, because our goal is to find all the zeros, are -1 and -3. And this is, I'm going to write dr for double root, because that's why you have 3 total solutions. You want to find all of them. Double root. Okay, so now I want to do one more example. Of course, because they aren't all this easy. I'm going to do a 5th degree, and where we even get some imaginary solutions. Okay, they don't get much harder than this, but they do take a little bit of time at first. So let's try, okay, so example 2 is going to be f of x. Feel free to work ahead of me if you've got this down. X to the 5 minus 2x to the 4 plus 8x squared minus 13x plus 6. All right. I want to find all the answers. How many are there exactly? 5. So I'm going to write degree equals 5. So exactly 5 answers. Sometimes that's all you have to do in the problem to say how many solutions. Now we might have like 1 double root and 1 triple root, and that might be it. That's 5. Okay? And again, if just preview, we'll see what this looks like graphically. Like when it's a double root and a triple root, it changes the shape of the graph. But now we're just finding them. Okay, so we're going to try 1. Let's do our synthetic in purple. Let's try 1. So what's the list of coefficients? Oh, nice. You remembered the placeholder. That will save you so much agony. You're missing the cubed term, so don't forget you need a placeholder for that 0. Okay, Kylan, what's the first step in synthetic multiplication? Synthetic division is what I meant. Copy, yes. And then? Yes. And then, okay. Multiply, add, multiply. This is supposed to work. Is it? Add. Yay. Multiply. Okay, to do your arithmetic really carefully. So, we've broken it down. Now we have, what's the factor? Since 1 works, Shahad, since 1 works, what is the factor that goes along with it? So do I write x plus 1 as one of the factors? Because 1 works?
X minus
The opposite, x minus 1 is a factor. Since 1 works, x minus 1 is a factor. That's the remainder factor theorem. Remainder is 0, so x minus k is a factor. Okay, so what's left over is we're going to break this down 1 degree lower. So instead of to the 5th power, it's to the 4th. 1x to the 4 minus 1x cubed minus 1x squared plus 7x minus 6. Wow, it's still kind of a large polynomial. Yep, so this part, we have no way of factoring this with 5 terms in it right here. So we're going to do it again. So we're going to try, and I'm just going to kind of tell you so we don't have like a bunch of notes of trying different things. I'm going to try -2. We're not just trying it though, I know it works. So we're going to use -2, and the coefficients are 1, -1, -1, 7, and -6. And we're going to see mama. So we copy, multiply, add, multiply, add, multiply, add, and yes, it works because we knew it would. Cheating a little bit. Okay, so now we've broken it down, and we know the factors are we've broken it down, and we know the factors are what? What do we have now? What was the first factor we found? Good, good. And what's the new factor we now know? Right, opposite sign. And then we're going to use these coefficients. Now it's cubed, right? We keep breaking down the degree. X cubed minus 3x squared plus 5x minus 3 equals 0. Now, do we have a way of factoring this 4 terms? We do, right? What's it called? Factor by grouping. But the reality, I didn't want to tell you this before. The reality is grouping doesn't always work either. Just because there's 4 terms doesn't mean the grouping will work. So, in fact, it won't. So, because you would take out x squared here, you get x minus 3, and then it wouldn't match, right, when you factor this out. So, I certainly try it, because sometimes it will. But when it doesn't, we have to try something else. So we have to break down the rest. So we're going to try 1, even though I know it works. So we'll do 1, -3, 5, -3. When you're trying stuff, let's just agree we're going to start with trying 1 and then -1. And then 2 and -2, and I'll make it, like on a test or whatever, I'll make it so that you get it within that. I'm not going to have you do a million rounds of synthetic division. So copy, multiply, I feel like that's not right. Multiply, you get 1, add, multiply, add, multiply. So now we have x minus 1 times x plus 2 times x minus 1 is our new factor that we just got from trying 1. And this we like, sort of. Yeah, you could write x minus 1 squared. Okay, we're almost there, but so our solutions here we see are 1 and -2. 1 is a double root. -2 is a we just call it a regular root. This, how are we going to solve that? This is going to be great review. Because what degree is that? Degree 2, what's the name for degree 2? Quadratic. We did a whole unit on just solving this. Because the diamond isn't going to work. What multiplies to positive 3 and adds to negative 2? And that doesn't multiply to positive 3. Right? There's nothing that's going to work here. So to solve this part, we're fine. We have x equals 1 and negative 2. And this is a double root right here. So that's done. That's part of the answer. But this we gotta solve. So, which is a great, just because you can't factor it doesn't mean it doesn't have solutions. We have two choices, quadratic formula or, what's the quadratic formula based on? The quadratic formula is, how do you prove the quadratic formula? Where does that come from anyway? Completing the square, right? So we're going to solve this by completing the square, and it's so much easier actually than the whole memorizing the quadratic formula. So let me just review for you, and then this will help you on your test corrections that you're about to do anyway. So we're going to solve this. Here we go. Step number 1 was to move the leading coefficient out of the way and to move this to the other side and factor out the leading coefficient. This is nice and easy because there is no leading coefficient. So my first step is to just do that. It's very simple. Move that out of the way. Okay, so who can tell me what to put in the magic box to complete the square? You take, yeah, you take half of this and square it. Half of negative 2 is negative 1 squared is 1. So we go plus 1, and you just add the same thing to both sides. We're almost there. This is factorable as a perfect square. That's why it's called completing the square. What multiplies to 1 and adds to negative 2? Negative 1 and negative 1. Those will always be the same, which is the whole reason we get to write it as a perfect square. Right? And we're almost there. This is easy to solve. When something's squared and you want to get rid of it, what do? You take the square root. So plus or minus the square root of negative 2. Please don't forget to do plus or minus the square root. And I'm almost there. So my other two answers are 1, right? You'd have to add 1 to both sides. 1 plus or minus the square root of negative 2, but that's really I root 2. And that was extra credit on your, one of those, I made that extra credit on the last test, but from now on you should know, if you have a negative under the radical, you get rid of it by putting I out front, because I is the square root of negative 1 by definition. And so those are my last two. So how many total are there? How many total solutions? Wait. It has to be 5. Yeah, good. The fundamental theorem of algebra says there are 5 solutions. So there's 2 right here. They're imaginary. 2 imaginary. 1, and then 1 double root and 1 regular root. And that's 5 total solutions. And I'm going to stop this recording, and maybe someday it'll make it online. Someday.